Hello, everyone. Welcome, and according to where you are in the world, good morning, good afternoon, good evening. This is the latest in a series of global webinars organized and sponsored by the Eye on Earth Alliance. My name is Derek Gludden, and I am the organizer and host for today's webinar. I work for the Environment Agency of Abu Dhabi, one of the founder members of the Eye on Earth movement, and I'm speaking to you from Abu Dhabi in the United Arab Emirates. Eye on Earth is a global movement launched in 2011. Eye on Earth's mission is to enable stronger integration of the environment in sustainable development by enabling all stakeholders to have the data, information, and knowledge they need. Guided by a suite of 14 principles aligned with Principle 10 of the Rio Declaration, Eye on Earth is about facilitating knowledge exchange within and between specializations and geographies. The Eye on Earth movement has two main components. First, a convening and governing partnership of some of the foremost data and information-focused organizations in the environmental dimension of sustainable development. And they are, in alphabetical order, the Group on Earth Observations, GEO, the International Union for the Conservation of Nature, the IUCN, United Nations Environment, the World Resources Institute, WRI, and my employer, the Environment Agency of Abu Dhabi, to whom a special word of thanks is extended for providing the staff time and enabling technology for this webinar series. The second and core component of Eye on Earth is yourselves, a multidisciplinary, truly global community of experts. The magnitude and diversity of knowledge within the Eye on Earth community is demonstrated by the number and distribution of people who have registered for today's record-breaking webinar. You are nearly 500 people from well over 80 different countries, and you represent every part of the globe. Whether you're attending the live event or watching afterwards, welcome. My pleasure and great privilege to introduce our distinguished speaker. Dr. Lucas Joppa is Microsoft's Chief Environmental Scientist. He is Microsoft's internal and external focal point on corporate matters pertaining to environmental science and the application of technology to solve sustainability challenges. Lucas is one of 10 thought leaders in the artificial intelligence sector. He oversees AI for Earth, the subject of today's webinar, a cross-company program dedicated to deploying Microsoft's deep investments in artificial intelligence, research and technology in the 4 key areas of climate change, agriculture, water, and biodiversity conservation. Lucas is based in the Seattle area of the United States, from where he speaks to us today, and where it is just 7 o'clock in the morning. So we extend a particular thank you, Lucas, for doing this. Lucas has a PhD in ecology from Duke University and a Bachelor of Science degree in wildlife ecology and zoology from the University of Wisconsin-Madison. He sits on the board of directors at NatureServe and is Honorary Conservation Fellow at the Zoological Society of London. He is Associate Editor-in-Chief of Ecosphere, the journal of the Ecological Society of America, and he has senior advisory positions at the Biodiversity and Wilderness Solutions Group, the National Socio-Environmental Synthesis Center, the US NOAA Advisory Committee for the Sustained National Climate Assessment, and the US Steering Committee for the IPBES.
Well, thank you, Derek, for the very kind introduction, and a very large and sincere thank you to the Eye on Earth Alliance for inviting me to present this webinar. The map that Derek showed just a few slides ago represents by far the most geographically diverse audience I've ever had the privilege of presenting to. So thank you to the Alliance for bringing those people together, and thank you for the opportunity to speak to everybody. And we'll touch on why that geographic diversity and representation is so important to what I want to talk about today a little bit later. But as Derek mentioned, I am the Chief Environmental Scientist for Microsoft Corporation. It's the first such role in the technology industry. And one of the principal reasons that Microsoft created that role was for me to create and lead this relatively new, about 6 months old, cross-company program called AI for Earth, which has as its kind of extremely ambitious mission to help global societies change the way that we monitor, model, and ultimately manage Earth's natural resources. And I think that, if nothing else, is something that nearly all of us on this webinar today agree on is a mission that we need to make some significant progress on, and make that progress relatively quickly. So the only thing I would really say about me, I guess, in all of this is that, as Derek said, I do come from the environmental science side of things. My background is in ecology. My undergraduate degree is in wildlife ecology. My PhD is in biodiversity conservation and ecology. And then from there, I took a slightly different career turn, and instead of going into a nonprofit or a government agency or going in and working at a university, I took an opportunity to go and become a researcher in a blue sky corporate research lab, an organization called Microsoft Research. And in some ways, you can think of that as the University of Microsoft, where a small select group of about 1,000 to 2,000 employees around the world are allowed to dedicate 100% of their time to think about the future of computing and the future of how computing is going to impact societal challenges. Now, I'm obviously an environmental scientist, and so I spent the first 7 years of my career focusing on this intersection between environmental and computer sciences, simply because I think that it's an underrepresented, underinvested in area. It accrues to the core competencies of the organization that I work for. And it's going to be critical to be able to answer a lot of the questions that people are asking at the global scale that we need to answer them. And so that's just a little bit of my background. What I want to say about AI for Earth and why Microsoft is actually investing, the public announcement in December of 2017 was that Microsoft was committing $50 million and over a 5-year period to this AI for Earth program. And the number that I really focus on there is the 5-year commitment, because from a technological perspective, that's basically a geological age. I mean, 5 years in the tech sector, if I've learned anything in my career at Microsoft, 5 years is an incredibly long time. An incredible amount can happen in that space. And so for me, I'm looking at this opportunity as something that basically, as far into the future as I can see, we as a company and me as an individual are going to be focusing 100% kind of our time thinking about how we can deploy our 35 years of research and technology investments in artificial intelligence to address the natural resource issues of today. And the reason that I think we're doing that is because of really the way that we as a company see the world and see our place in it. And it's really that we are one of the founding members of what people call the technology sector. We were there from the beginning, and we helped build the infrastructure and the architecture of today's modern information age. All of the technologies that I use to put this presentation together, the technologies that we're using to communicate on a day-to-day basis, and so forth. This really ubiquitous computing that's come to consume nearly every aspect of many of our lives, that is the area of focus that we have had for the past, well, since our very founding. However, we're also completely aware and very clear-eyed that we're doing business at a time of unprecedented societal challenges. And I don't think I'm showing my environmental bias too much by saying that one of, if not the greatest societal challenges is this unprecedented one of we as a human species having to both mitigate and adapt to changing climates, ensure resilient water supplies, sustainably feed a human population rapidly growing to 10 billion, all while stemming this ongoing and catastrophic loss of biodiversity. And so as a company, we spend a lot of time thinking about what it means to be doing business at the intersection of these two ages. And one of the things that we've come to realize is that for us, one of our grand challenges is figuring out how to deploy the architecture of the information age to counter some of these societal challenges, in particular issues around environmental sustainability. And so we see the world as one filled with incredible challenges, but we also see it as one filled with incredible opportunity and promise. And that's really in large part because of the advances that we've been seeing happen in the area of artificial intelligence and machine learning. And I think one thing that's almost impossible to overstate is just how rapidly innovation is happening in this space. When I was a peer researcher in Microsoft Research, we were constantly asked to think 50 years into the future of computing. And so that's what we came to work every day doing, trying to think 50 years out. But what's so humbling is realizing just how difficult it is to think that far out ahead when the technology behind you is running so fast to catch up. And the things that we thought were 50 years out turned out to be about 5 years out. And now Microsoft and all of our other industries or companies in the technology industry are starting to ship services based on that peer research from just a few years ago, starting to ship that out to the general public on a day-to-day basis. But I just wanted to say something really briefly about artificial intelligence, machine learning, deep learning, and the time that we're in. And that's really that this idea of artificial intelligence is far from new. The term was really coined back in 1956 at this small gathering of computer scientists and other academics at Dartmouth University, where they described this or came up with this vision that human intelligence could be so precisely described that any machine could be taught to replicate it. And that's what we meant by artificial intelligence. But at that time, we didn't have the computational capacity that we do today. And so the way that we were approaching that vision of describing human intelligence in computational systems was by really kind of if then else sorts of expert systems, right? So we were trying to learn the rules by which human intelligence operated and then code that into computational systems. It was actually a few years later, in 1959, that Arthur Sengel coined the term machine learning. And that is what really started to allow us to start to make rapid progress towards this vision of an artificial intelligence. Because what machine learning was about was building computational systems that were able to learn themselves simply by being presented with data. Instead of having to hand code what the machine should do, the machine can learn itself what it should do based on data that was collected from previous experience. And then, there's the real significant breakthrough, I think, over the past few years has been in an area of machine learning called deep learning. And that's really just an algorithmic approach to teaching computers using data that is thought to emulate the way that human brains are structured, but it's really just taking advantage of a long ago proposed idea of neural networks, making them significantly more complex and presenting them with significantly more data. And when we take a deep learning approach to some very common tasks, things like image classification or speech recognition or language translation, then we see that for the first time, now we're able to build computational systems that are as good or better than human capacity in those limited domains. Now, the reason really that we're able to do all of that is not just because of, you know, some specific algorithms like deep neural networks. It's really about all of this stuff coming together. This is why you hear about artificial intelligence breakthroughs almost on a daily basis. It's because we have this flywheel now spinning at an ever rapid rate, where we can take unprecedentedly large and diverse amounts of data. We can host those data on incredibly scalable infrastructure in the cloud, in massive server farms all around the world. We can confront those data at scale with these increasingly complicated and agile algorithms. We can take the results of the models that we train using those algorithms and those data, and we can allow people all around the world to access them via application programming interfaces or APIs. And then we can consume those APIs in higher order applications that have, you know, customized user interfaces and sophisticated user account management and all of that. And it's really those things coming together that has led to this AI revolution. And it's why, if you ask the World Economic Forum, for instance, whether or not we're in a new fourth industrial revolution, their answer is a resounding yes, principally because of the advances that artificial intelligence will be contributing to the global society over the coming years. Now, at Microsoft, we're basically infusing artificial intelligence across all of our platforms and services, everything from, you know, typical things that you already know about, things like Microsoft PowerPoint. In fact, when I was putting together this PowerPoint presentation, there were machine learning algorithms constantly making recommendations about how I should design it so that my presentation would be more visually compelling, how I should design it so that my presentation would be more accessible to those with a wide diversity of abilities, and so on. But where we're really going next is thinking about how we deploy not just artificial intelligence into all of our software and services, but also into the application areas that we care about. And those areas really are, as I mentioned before, these four key areas of climate, water, biodiversity, and agriculture. How can we deploy our AI and the technology sectors in general, the sector's advances in artificial intelligence that really help change the way that we observe data or information about Earth's natural systems, how we communicate those data all around the world, how we classify those data into meaningful entities, how we make predictions from those classified data, and ultimately how we can optimize over those data to make better decisions about managing natural systems. And that, of course, is a monumental task, but we are committed to working across what we see as kind of the three barriers to leveraging our artificial intelligence technologies in these 4 key areas. And that's really around allowing people to access our technology, providing individuals and organizations with education and training about these technologies, and then jointly collaborating and innovating with a few organizations to produce applications and solutions that we think really do have the potential to provide meaningful impact at a regional or a global scale. And so AI for Earth, as I said, was announced about 6 months ago. And in that time, we've made fairly significant progress in each of these 3 key areas. And that's what I'll kind of cover in the second half of my talk. And so the first thing that I would mention is just the first offering that AI for Earth has made is just raw access to our cloud infrastructure and our artificial intelligence software and services that live in the Azure cloud, Microsoft's cloud. And so that's just through a simple grant making program that we have. I'll have a call to action in my last slide where you can learn more about that. But it's a simple application process that gets people up and running with the cloud computing and artificial intelligence resources that they need to take a machine learning approach to working in the 4 areas that our program focuses on. And my map is nowhere near as impressive as the map that Derek showed and that represents all of the participants in today's webinar. So we have about 110 grantees in the first 6 months that we've been in existence, 110 grantees across 27 different countries and about 25 different states in the United States. Now, over the 5-year course of this program, I have a much greater ambition for what this map will look like. In fact, I would like to see at least one marker in every country in the world. And I think that by looking at the map just of today's webinar, I'm not being overly ambitious in what we hope to achieve from a grantee perspective. One of the principal reasons that I was so enthusiastic about joining today's webinar is to be able to reach such a geographically diverse audience. For me, having applications and grantees working in all reaches of the world is one of the easiest ways to bring in a diversity of perspectives of not just what the problems are, but how we might be able to solve them. And so I look at this map and I think that our program has made incredible progress in the past 6 months. Like I said, we went from 0 to 100, well over 110 now grantees in almost 30 countries, but we have a long way to go. And I'm looking forward to working with many of you that are listening to this webinar over the coming years to have you join the current portfolio of grantees on this map. The second thing that we focus on really is this education pillar, where we're looking to provide training both in person and in digital format to the domain of machine learning and artificial intelligence more broadly, as well as the tools that Microsoft makes available. And for that learning process, that education process, this is something that we share in common with the Eye on Earth Alliance, is we want to start to help build that global community where people are able to gain training and education, not just in a formal way, but in an informal way from their peers and their collaborators, but folks that maybe they never knew were their peers or knew were their collaborators. And so the way that we're working on that is through aspects of classroom-based learning. In fact, we just finished up with our second AI for Earth Education Summit here at Microsoft headquarters. We had about 40 grantees from around the world join us It was a fantastic opportunity to get to know our grantees better, but even more importantly, it was an opportunity for our grantees to get to know each other, as well as the technologies that they had access to. We have things like office hours with machine learning experts and principal engineers on my team that can help people with their particular grantee-related issues. We provide access to online learning platforms like LinkedIn Learning and the vast digital curricula that LinkedIn Learning provides, and on and on. So that really is what one of the big benefits for the grantees that join our AI for Earth community is they don't just get direct grants from Microsoft, but they get access to this broader network of collaborators around the world. And then there's this last pillar of the program called innovation. And by that, we really mean some of our deeper investments in approaches and projects and organizations and applications that we think really do have the potential to scale. And one of the areas that I've been thinking a lot about my entire career is how we scale up global biodiversity monitoring. What we know after over 100 or more years of studying biodiversity on Earth is that we know very little about it, right? Best estimates are somewhere around 10 to 12 million species on Earth. Estimates range as high as 50 million. Well, we've described about 1.5 of those million. The vast majority of those have been described and simply exist as a simple collection in a museum. The IUCN Red List, a hugely important global initiative that I've been collaborating with for a long time, has done this amazing job of providing fully baked conservation assessments of as many species as they possibly can all around the world, has completed a global assessments of mammals and birds and amphibians. But if you look at the total number, you see that it still represents this tiny fraction of all likely life on Earth. And so how are we going to change that? Well, one way that we are thinking about that, and others have been well before us as well, is through citizen science. And I know that there was a webinar on this very topic very recently, and it's a hugely relevant one. The organization I want to talk about today is one that many of you might already have heard about, an organization called iNaturalist, which produces a extremely popular biodiversity monitoring platform for citizen scientists. And I'm really pleased to say that a few months ago, Microsoft and iNaturalist entered into a partnership for AI for Earth to provide the technology support and additional machine learning expertise for iNaturalist to go from what they currently are to a future vision. And just a little bit about iNaturalist. I think it's seen this incredible growth over the past few years. These numbers are actually now wholly out of date because they're on an exponential growth curve. And I collected these numbers just a few months ago. And at that time, they had over 500,000 users, over 6 million observations, verified biodiversity observations recorded across 120,000 distinct species. And as I said, that's pretty, that's a little bit out of date. But what does iNaturalist actually do? Well, it really just relies on both experts and novices alike to collect information through imagery by taking photos of species that they see, either when they're out purposefully looking for those species or when they're just kind of on their walk-in from work. And they get data sets of both kinds. And so you know, how does iNaturalist currently work? Well, it collects information about the date and time, the lat and long, and an image. That's really the kind of the scientific collection there. And if that image is taken by an expert user, somebody who knows a lot of species, then that expert user can classify the species in that image down to its common and Latin binomial names. And that classification can go as a verified species identification. But the vast majority of people don't know the vast majority of species that they encounter. And so those are novice users. And in fact, experts can be novices as well, because most people are only experts in certain taxonomies. And so when you take a photo on iNaturalist of a species that you don't know, you need to ask the community what that might be. And so that comes back again to these expert users. Well, taxonomy and taxonomists aren't a profession that's on a rapid growth curve. And so the amount of data coming in is a huge burden for these expert users to actually go through and classify themselves. So the question is, how can you release the burden on those users and allow them to be freed up to spend more time thinking about the difficult unknown species? And I'm just going to skip that slide and go here, which is that, you know, from a Microsoft perspective, and actually from an iNaturalist perspective as well, it's obvious that one way that you can try to do that is by using computer vision. We can take the expertise that has been contributed to the iNaturalist platform, so we know what species are in what images. We can try to compress or consolidate that expertise into a single algorithm that's able to, for a large percentage of species, assist novice users, right? And make recommendations about what species they may have just taken a photo of. Because you might not know what the name is of any particular species that you just observed. But if a computational system says, well, I think it's this thing, and if it's not that, it's probably one of these 4 other things, then even most novices are able to choose which of the 5 examples best match the image that they just took or the species that they just took. And then, of course, we can add into that things like species distribution modeling, so that that's not just based on the image that's being taken, but the time and the place and potentially the bioclimatic variables, so that we can have a machine learning model underneath that's putting together the probability of this being, for instance, an American robin, which happens to be the state bird of the state in the U.S. where I grew up in, and the probability of that particular species existing in a place where I took a photo of it at that particular time, putting those together as joint probabilities and making an ultimate recommendation. We can also use those species distribution models to be able to help direct citizen scientists more efficiently. So we can say things like, hey, if you would like to see such a species, we recommend you go here or there. Or if you would like to help improve the prediction of our models, then we would recommend you looking for this species in this place, because from an statistical perspective, such an observation would have the most information attached to it. So that's one project that I'm really excited about, and excited about collaborating with iNaturalist over the coming year. The second project that I wanted to talk about is one related to remote sensing, and that's really a desire to change the way that we do land cover mapping, both here in the U.S. and more generally. And so what do I mean by that? Well, not to take too much of a US focused view of things, but since this is where I live, I at least like to think about problems through the lens of this place. And I see that while we've had an explosion of high resolution remote sensing platforms, from satellites to drones and everything in between, we still are about 8 years out of date and at 30-meter resolution on a national land cover map. That makes it really difficult for us to understand what is where, how much is there, and how fast it's changing. Where are our fields and our forests? Where are our waterways and our urban centers? To a large extent, we're not able to track those things. We want to be able to change that. And so we started working with a small organization called the Chesapeake Conservancy and a large organization, which I'm sure many of you are intimately familiar with, called ESRI, right? The providers of geographic information system software to organizations all around the world. And we wanted to try to change how land cover mapping was done. And we started small, and we started with a particular project. We started by a project that the Chesapeake Conservancy and their partners in the Chesapeake Bay Watershed Program had been working on, which was trying to build a 1-meter resolution land cover map of the Chesapeake Bay watershed, a hugely important and critical watershed here in the United States. About 100,000 square miles, 2 terabytes of imagery. And it took them about 18 months to make that map. Well, by the time that map was made, it was already out of date. So how are we going to improve that? Well, from our perspective, again, we were interested in the algorithm side. We could take that map that the Chesapeake Conservancy had produced and treat that as labeled data. So hundreds of millions of labeled data points that we could use to train something called a deep convolutional neural network, a special type of deep learning. We could build a model that then would be able to consume any new images of this type and produce land cover maps on a rapid schedule. And so that's exactly what we did. I think for any of you who are statisticians in the audience, I think that anytime you're confronted with some of these deep learning models, it's fairly terrifying, because the number of parameters that these things contain can just be fantastically large. But nonetheless, they tend to work. So this is what we did. We were able to train a model with about 300, a little over 300,000 parameters over 23 different layers, using a Microsoft deep learning toolkit called the Cognitive Toolkit. Trained it up on graphical processing units, or GPUs, and we were able to build a model that then we could integrate into Esri's ArcGIS desktop platform, ArcGIS Pro, where here in the top left, you see it says NAPE. That's raw 1-meter 4-band imagery coming in from the National Agricultural Imaging Program here in the United States, in a location in Oakland County, Michigan. And in the upper right, we have the old land cover map for this county. It was taken about 8 years ago. You can see that things have changed a lot. That T intersection in the road has been redeveloped to be a roundabout, but that's not represented in this county's map. Well, what we were able to do is, by taking our model and communicating with it via the raster functions in ArcGIS Pro, we were able to take this raw 4-band imagery, pass it through our model, and immediately return the results that we see in the bottom right. And these are our classified model results. And you can see that we were able to update that almost immediately. The image to the left is actually a probabilistic view of what is what. And so that's where you can kind of see model confusion across several different classes. For instance, these cars on this roadway being picked up as separate or potentially confusing objects, but then ultimately the model decides that no, actually we should call that road. And I'm not showing this live, but when I presented this at the Esri user conference last year, what we were able to do is pan around anywhere in the United States and see the results here. Now, I should say that not everywhere in the US does this work well. There's still a lot of work on the modeling side to make this as accurate as possible. But it's not just Esri's ArcGIS Pro software that we can include this in. We can use Esri's web apps to build simple web applications. This is actually the town I grew up in northern Wisconsin here in the US, where we're able to click, immediately get results back. And this is an internal tool that we use to help our team identify which algorithm is doing the best in which area of the United States. And so we have different algorithm outputs being presented here in the user interface. And this has also spurred on a whole lot of other research across the team. So can we actually take some of our old data sets, for instance? So here, many of you might be familiar with things like globe cover or global land cover or Landscan, some of these global 30-meter resolution data sets. Well, it turns out we can use the same sorts of techniques that your smartphone uses to take potentially not great quality photos and then use software through that runs algorithms, super resolution algorithms. Many of your phones are doing this live or anytime that you take a photo. So we use the optics in your phone to take a photo. That photo might not be that great, and then we super resolve it. We sharpen the photo using machine learning. And we're able to use those same techniques to take old data and sharpen it down to what that current land cover most likely is. And that's some of the most kind of cutting edge research that we're submitting to top computer vision conferences around the world. But then once we have models like this, the big question is, how do we run them at scale? How do we take advantage of the vast computing systems that a company like Microsoft has to be able to make it both cheap in time and money to run these sorts of models? And this we just showed at one of our large Microsoft conferences. It's by taking advantage of a new product in the Microsoft Cloud called Project Brainwave, where we have machine learning algorithms running on FPGAs, or field programmable gate arrays, which are a special kind of chip that you can program to be extremely fast for one task or another. And by doing that, we were able to take about 800 FPGAs, about 800 cores in Azure, process about 195 million images at about 415,000 images a second, with about 1.8 millisecond latency across 20 terabytes of imagery to produce a national land cover map, a 1-meter resolution national land cover map, for $42 in 10 minutes. And those are the sorts of results that I find to be completely game-changing in our ability to really get out ahead of this exponentially growing amount of geospatial data. And that's a vision that both Microsoft and Esri share together. In fact, late last year, I should say, we formed a new corporate partnership around something called GeoAI, which is really about integrating Microsoft's artificial intelligence toolkits with Esri's GIS platforms, so that we can really deeply embed machine learning and AI in this full GeoAI project lifecycle. So, and I'll talk about that in just a second. We have quite a bit of ambition in this space, but the first product that we brought to the market is one that anybody in the world can actually go and access for a cost, but any of our grantees can access for free something called the GeoAI Data Science Virtual Machine, where we've brought together all of these popular tools, whether it's R, Python, Esri's ArcGIS Pro software, new languages, Jupyter Notebooks, SQL Server, basically it's a one-stop shop for data science. We've built that in such a way that it's amenable to geospatial researchers. With one click, you simply get a machine that comes pre-installed with all these tools, so you don't have to do the hard work of doing it yourself, and you can get off and running. And so that for us is something that we've received a lot of positive feedback on how helpful that has been. I've put these slides in here. I'm not actually going to speak to them, but there's some text here that you can read through. These are just two other projects that I'm really excited about in the AI for Earth portfolio. Project Premonition, which is really using mosquitoes as data collection devices so that we can try to monitor biodiversity in a completely new way using metagenomics in the cloud. And FarmBeats, which is trying to provide an end-to-end solution, including new connectivity. So basically things that you can think of as super Wi-Fi to be able to allow farmers around the world to take advantage of this revolution in precision agriculture, even if they're not large enterprise agricultural companies. How can we reduce the cost and increase the simplicity of these solutions? And so I'm almost done with my talk here. I just wanted to say that moving forward, the way that AI for Earth wants to support our grantees is in a more nuanced and sophisticated way than we have been to date. We want to be able to support the full algorithm lifecycle. We want to help support those who have unlabeled data, get them labeled so that they're ready to be ingested by models that can be trained on them. For organizations that have labeled data, we want to be able to assist with the creation of algorithms and models. For those models that are completed, we want to be able to help deploy those as APIs in the cloud so that everyone around the world can access them. And for those already with sophisticated applications and large user communities, we want to be able to help re-platform, stabilize those applications in the cloud so that the organizations that support them don't have to worry about necessarily the IT aspect. And so the thing that we'll be working towards is producing an offering where you'll be able to access tutorials, code, and sample data both on a website as well as on that GeoAI data science virtual machine that I just described. Be able to access trained models, be able to consume model and data APIs directly from the Azure cloud, and be able to find out more about these applications that we support. And this is just a very early look at a provisional design of what we'll be rolling out in the coming year called the AI for Earth Gallery, where all of this will be made available. And so the two things that I would just like to say on this last slide of my talk is, first, thank you. Thank you for the unprecedented interest. I know this has been the largest registration for an Eye on Earth Alliance webinar to date, and that is just a fantastic proof point for me about the interest in this topic area, that we as a program are on the right track. And then the second thing is we hope we're on the right track, but we do need to hear from folks all around the world on what, in particular, what problems they need help solving, how AI technologies can help them solve that. And so the call to action here that I would leave you with is, first, please go and visit our website. The link is at the bottom of the screen here. There's a section on that website that will allow you to apply for a grant. If you have an idea for how you can use Microsoft's AI technologies in the 4 areas of ag, water, biodiversity, and climate, please fill out the simple application template and come join our grantee community. And secondly, if you think you have specific ideas for particular models that would benefit from being hosted as APIs in the cloud, where organizations around the world would be able to consume them, please write to us at AI for Earth APIs at Microsoft.com and briefly describe the model and the potential interest and consumer audience, and we would love to hear from you. And with that, I will wrap up my side, and we.
Fantastic, Lucas. Absolutely awesome presentation and some amazing opportunities there. As you say, we'll now pass over to spokesperson from the Eye on Earth Alliance, Dr. Tom Brooks, the Chief Scientist at the IUCN, the International Union for the Conservation of Nature.
That's great. Thanks so much, Derek, and above all, thanks to Dr. Joppa. Thanks to Lucas for this amazing seminar. I'm delighted to have the opportunity to lead the vote of thanks to Dr. Joppa here on behalf of the entire Eye on Earth Alliance, and specifically on behalf of the 5 partners Derek highlighted at the beginning: Environment Agency Abu Dhabi, Group on Earth Observations, UN Environment, World Resources Institute, and International Union for Conservation of Nature, where I serve as Chief Scientist. Particular thanks, I think, are due to Lucas for coming in with such an early start from Seattle. And I should also really emphasize very warm thanks to all of you, to all of the participants. As has been highlighted, we had more than 500 registrants for the webinar from 75 countries, and more than 150 live participants on the webinar today. So even in advance of the electronic connectedness that we see today, and that Lucas has highlighted a number of dimensions of for the last half hour or 40 minutes or so, it never ceases to amaze and indeed to terrify me on how small our world really is. As a case in point here, Lucas and I, in fact, shared the same PhD advisor, Professor Stuart Pym from Duke University, who I think it's fair to say taught us both very many crucially valuable lessons the hard way. Moreover, Lucas and I have then worked alongside each other for a number of years through roles that both of us have played on the Red List Committee, the body that governs the IUCN Red List of threatened species, as a mechanism to measure and document species extinction risk, as Lucas highlighted in the first half of his webinar. Now, in his leadership role at Microsoft, Lucas is clearly breaking very much new territory in supporting the environmental community, as embodied here by the Eye on Earth community, in identifying ways in which AI can be put to the service of sustainability of life on Earth. In addition to the applications discussed today, I'd highlight a couple of other areas of particularly exciting potential. One is the automated identification of individual animals. We heard from Lucas about identification of species, but identification of individual animals, think about giraffes or whales or big cats or salamanders, is one frontier area of application of AI for supporting life on Earth. Thinking about responses, there's huge potential of AI to support detection of patterns in illegal activity. Think about illegal deforestation or fisheries, water use, and wildlife crime. And then one final area that I'd really emphasize, and indeed that I know Lucas has been looking at, is to support the harmonization of land cover change detection. So building from the kind of work that Lucas reported on application of AI to land cover mapping, to then help to inform in turn assessment of risks of species extinction and risks of ecosystem collapse. I'd also like to emphasize the importance of seeing AI as a tool to support the ever-challenging task of mobilizing capacity on the ground for field work. This is fundamental for sustainability on our planet. AI should supplement and strengthen such boots on the ground and never be seen as replacing them. And this came through to me very strongly from Lucas's comments, above all in the brilliant iNaturalist example that he highlighted. AI as a way to strengthen the kind of data that people can generate through getting out in the field and democratize those data such that everybody can generate them. In closing, I'll echo Lucas's call to action to urge webinar participants to follow up at the AI for Earth APIS at Microsoft.com with any questions, and to visit the AI for Earth website to hear more and to apply for grants. So thanks again, Lucas. That was a fantastic presentation, and we all look greatly forward to the contributions that AI overall and AI for Earth specifically can contribute towards our shared goals of mobilizing data in support of and tracking progress towards the sustainability of life on Earth. Thanks very much.
Thank you, Tom. So now we'll turn over to questions. Aaron Gilby. Aaron, I'll open your mic.
I'm a UX researcher who is focused on sustainable development. I organize in Germany a group of individuals who are concerned about the environment and have a strong set of technical skills. Here in Karlsruhe, Germany, we have also successfully held a climathon, like a hackathon for climate sciences last year, and it looks like it's going to be happening this year as well. It's hosted by the city. Just to let you know that there's also a strong government policy push here as well. How might I connect this local movement for AI, with AI for Earth without necessarily being isolated or being disconnected from the larger network?
Yeah, sure. Thank you so much for that question. I think actually it gets me to kind of a broader point, I guess, as well, which is that one of the reasons that we focused on this kind of APIs and applications layer for how the program can contribute kind of at a global scale is because it came from that same level of questioning and potentially frustration that I think you experienced. Not saying that you were frustrated, but I was. Which is I participate in a lot of those sorts of events as well. And in fact, you know, I participate in them through publishing academic papers where my results then go into a PDF and people can read it and cite it, and maybe do something more with it, but that's kind of it. But all my technical contributions aren't really available. I work with and sponsor hackathons, and I see the incredible contributions people are able to make in a very short amount of time. In fact, we actually dedicate an entire week of our business year here at Microsoft, and it's coming up to our 1 week hackathon. So we kind of shut down, well, we don't shut down operations, but many of our employees all around the world just dedicated to hacking on particular projects. So for me, the question though is, well, then what, right? To what end? And, you know, sure, you can publish your code on GitHub, or, you know, you can do various things, but how do we take those results, package them up in such a way that it doesn't just stop there, that the results that were achieved are available to everybody, and not just kind of available in name, but actually available in technology. Like you could actually potentially consume something that was created. And that's why there's kind of this push and pull mechanism here, where I hope to evangelize a little bit that when people are participating in those sorts of activities, they focus on the sorts of outcomes that are most amenable to being kind of globally democratized, if you will, which is how can we take data or models and expose and get them produced in such a way that they can be exposed to the entire world? And then how can we and organizations like us work to help assist the exposure of that data and those models? And so that's really kind of the push and pull. I'd be happy for you to reach out via that email alias just to let us know more. But that's really the way that I think that it can work is when you work on those particular topics, be thinking about the ways that the future longevity of those projects.
Great, thank you. I'm going to move on to the next question. So now we have another question from Zoe Jewell. Zoe, if you can put your question, but before you do, just to let you know that a good friend of Iron Earth, Professor Ahmed Badavi from the University of Tehran, has asked a somewhat similar question.
Great, thanks. First of all, I'd just like to say what an impressive presentation. I only managed to catch the second half of it, but I wish I could see the whole thing. Really a comment that was made by Dr. Brooks at the end, suggesting that one of the priority areas moving forward with some of these technologies is to look at identifying individuals. This is something we do at WildTrack, using non-invasive approaches. And I was curious to know if you could describe in a little more detail how you see that integrating into the AI.
WildTrack is obviously a fantastic example of trying to get down to, well, using non-intrusive monitoring by looking at tracks of animals and being able to classify them down to species. But then, again, potentially even more importantly, being able to classify those down into individuals. So it's not just, well, we know that's a zebra, but we know that's Ziggy the zebra, or the zebra for those of you from that part of the world. So for us, it's really, there's from a computer vision perspective, we look at an image and we ask, can we simply classify that image? We don't look for any objects in it. We just say, in general, that looks like an image that has a zebra in it, for instance, right? And that's one class of computer vision type problems. A second category is object detection within that image, right? So can we delineate distinct entities within an image? That's a second type of difficult problem that a lot of progress has been made on. Then the third bit is, once you have that object, can you identify what the object is? And then the third type is, once you have that object, can you identify which of all of those same objects it is, i.e. individual identification. The interesting thing about individual identification is that it oftentimes requires a data set so we can tell if it's unique, but we can't necessarily tell you who it is until a human labels that, right? And so that's the only issue with scaling individual identification of species in imagery, whether that's image of the species itself or image of some artifact that the species leaves behind, like a footprint in the sand, is that algorithms can tell you that we haven't seen this individual before, but there's still a need for a human to tell you, well, then that must be Bobby the bobcat, right? And so that's really, for me, the only kind of hang up there. I mean, but other than that, that's kind of the perspective that we take on it. And quite frankly, we want to be able to support those applications because, Derek had mentioned there are several people asking a similar question to you. Well, we hear this question hundreds of times, which is species classification, imagery, object detection, species, so those are the types of problems. It's one of the reasons that we look for feedback via that email alias, is because the top problems that we look to focus on and make progress on kind of a platform level are those that we hear the most enthusiasm for from our grantee community, because generally that's a pretty strong proxy for things that people find important and will use in their downstream work. So we have a bunch of people working kind of full time on those types of problems, and we're really excited about the potential solutions that we might be able to bring out in the coming months.
So we have a number of people with a question on the financing or the costs of engaging in this. Lorenzo de Somon, Debbie Jewett, and Jared Boss have all asked a question.
Yeah, so the costs of accessing the resources are quite minimal if you receive a grant. In fact, they're free for generally. The typical sizes of Azure grants that we give away right now are between $5,000 and $20,000. There's a specific reason for that. It's because we like to see projects that are scoped down to be able to prove that they have the potential to scale before we make any larger investments. And so that is the one thing that I do try to get across, is when we start working with grantees, we do like to start small, not because we don't have a big vision, nor that we believe our grantees don't. It's because there's too many ideas that are all potentially valid for us to be making big bets straight out of the gate. And I think that land cover mapping example that I shared is a fantastic one. That started with a small grant and grew into everything that I presented today. Now, the business model side, well, I guess there's two aspects of this. One, there's the business model of the organization that's partnering with us, and then there's the business model for Microsoft. I mean, look, from Microsoft's perspective, we get an incredible amount of value out of working in this space, because one thing that I've learned over my time here at this company is that when we go looking for big problems to solve, so maybe we have a hammer and we're looking for a nail, if you will, we've come up with some new technology and we're looking for kind of the biggest, baddest problem that we think we could deploy it on, it almost invariably ends up being an environmental problem, because these are big, hard problems to solve. And if our technology works on them, then it works on many, many, many others. And the reverse is not necessarily true. So why not focus on some of the big problems straight out of the gate? It's good for our technology. It's good for the outcome. The second bit is that when you start talking about the environment, if you truly want to, or when you start talking about kind of cloud platforms and inclusive cloud platforms that offer technology to a wide array of industries and organizations, the environment is kind of, and natural resources is kind of the lowest common denominator, right? You're talking about water, biodiversity, climate, ag, air, soil. I mean, if you can produce services that meet the needs of organizations in those domains, then you've covered a large sector of the economy. And that really is where we're just in the beginning phases of, is because we understand that the world's a large, diverse place, and focusing in this space helps us fully grasp the extent of that diversity. And then I know this is a long answer to the short question, but the last bit I just wanted to say is what's great about model development and API hosting in the cloud is that it changes a business or a cost model, or COGS, or cost of goods, so that a lot of it is upfront, right? It's upfront because you have to get the data together, you have to host it, you have to train a model, etc. But once you've done that, then the cost of goods for simply hosting that model and allowing people to have programmatic access to it decreases markedly, and there's a way, an easy way for the owner of that algorithm to potentially monetize or subsidize the cost of using it. And so that's why, for me, the business model is quite compelling. So,
thank you, Lucas. I wonder if we can make one last question, and I realize the time, so if maybe it can be a very short answer. There was a question from Monaco Miguel Lago on a slightly different topic area. She's saying, regarding the education process, what, in your opinion, are the main gaps between the offerings today of academic and of vocational training and the expected expertise needed in the skills for the future? So I guess this is really a question around the kind of the skills gap. Any quick thoughts on that?
Yeah, I mean, I think, you know, things are evolving very, very rapidly. I think that it's easy to say that, well, everybody needs to have, you know, expertise in everything, right? Well, everybody should have to take computer science courses. Everybody should have to take machine learning courses. Everybody, well, that only goes so far, because the world doesn't need, you know, a society full of what, you know, we would say a jack of all trades. What we need are people who understand just the basic fundamentals of all of the tools that they need to bring to their specific area of focus. And I would say that we haven't caught up on the actual, there's two things that need to happen. There's an education and awareness gap that needs to be closed between people who focus on particular domains, like the domain that AI for Earth focuses on, and their awareness and ability to use some of the tools. But then there's also an education requirement on the tech sector's side, which is becoming more aware that you need to make these tools more simple to use if you want people who aren't computer scientists to use them. And that ties back to my answer to the other question as well, which is that by focusing on people using our tools for real challenges, it quickly highlights the places where our tools are easy to use and a natural choice, and difficult to use and thus an unnatural choice. So that allows us to focus on what those difficulties are and work on the usability of our tools to satisfy the demands of our users. And so that's really, I would say there's a joint education requirement, both on the part of technology users as well as on the part of technology producers.
I need to bring the webinar to a close now. I can't thank you, Lucas, enough for this stunning, amazing presentation and the fantastic, you know, offer of collaboration that you've extended to the community. There's clearly a vast amount that can be done here, and the power of the technology that you've been describing is as you said yourself, it's game changing. So a final word of thanks to everyone who's been in the audience today, record breaking in terms of numbers, and a fantastic outreach. Thank you for all the questions that you've put. It's this networking of people from around the world is what Ion Earth is all about. So thank you, and until our next webinar, which is about Resource Watch by the World Resources Institute on June the 20th, goodbye and have a great rest of the day.